Hello there, fellow explorer. I'm Maxine Dominique L and I'll be your tour guide for today. I hope you're excited and well prepared as we are going on a trip to John Hospers' Introduction to Philosophical Analysis. For today's trip, we'll be exploring the way the world works based on scientific knowledge. Do you want to know why such things occur? Come along with me as we have a long journey ahead of us. With that being said, here's our agenda for today's trip to scientific knowledge. We have a lot of destinations that we need to explore. So, let's explore them one by one. To start, let us first know what scientific knowledge is all about. To make it simple, common knowledge is what we encounter every day, like our everyday conversations with people, enhancing and practicing our skills, and the lessons taught in our education. While scientific knowledge is what we test or learn through systematic practices or thinking by using methods of investigating nature that discovers reliable knowledge. But both of them are very important as they are still required to study further and are still encountered and used in our daily lives. Now that we have learned what scientific knowledge is all about, let's take a step further and move on to regularities. Regularities are what considered as normal occurrences, things that happen in a usual or constant way. In other terms, regularities are also referred to as patterns. We all know that patterns are regularly repeated arrangements. Such examples of patterns are designs made from repeated lines, shapes, or colors on a surface. We also encounter patterns in our everyday life, such as in counting numbers, because the patterns of these numbers are constant and can be interchanged. As we observe the world, we notice certain regularities in the course of events. Regularities are patterns in nature, but not all are constant. Thus, George Santayana called these regularities as the thin red vein of order in a flux of experience, since regularities follow a certain pattern or order. Some regularities do occur, however, most of them are not invariable. When we talk about invariable, this means that it is never changing. Like for example, if we see the sun low in the west, we can predict that the sky will soon be dark and that we will be able to do activities that need more light. Sometimes, we think we have found a genuine invariant when further investigation shows that we have not, such as in the boiling point of water. We may be certain that water always boils at 212 degrees Fahrenheit, but when we climb up to the mountaintop, we find that the boiling point of water is somewhat less than 212 degrees Fahrenheit. The boiling point is not invariable as it changes when we go to a mountaintop. Since this is consistently observed, we discover that the boiling point is not dependent on the temperature, on the moisture in the air, and on the time of day, but it is dependent on the pressure of the surrounding air. Through this, we can formulate a statement on invariance about the boiling point of water. But there are also such things called as irregularities. How are they different from regularities? So regularities are the same things that happen in the same circumstances. They refer to the quality of being stable and predictable, while the irregularities are the opposite. They refer to the quality of being inconsistent or unstable. So irregularities ay yung mga naging kasanayan natin, while irregularities ay hindi ganon. So now that we know the difference between regularities and irregularities, let us now try to apply these concepts to the laws of nature. Heads up, we are now moving on to our next destination/agenda of our discussion. So science is a systematic search for uniformities in the way things behave, and these uniformities are called laws of nature. So what are laws of nature? Let us compare them to the laws that we abide by, which are referred to as laws of society. Laws of society, also referred to as laws of man, are the formal rules that society makes for itself. These are laws made by us, humans, or citizens. Usually, when we talk about a law, we define it as an act issued by a head of state or enacted by a legislative body, usually by the government. These are standards, principles, and procedures that must be followed and obeyed. Laws in this sense are prescriptive, which means that they determine and control how people are supposed to behave or not behave. With this, if we disobey these man-made laws, we will be facing the consequences or we will be punished. These laws may change from time to time, depending on the type of society, culture, and location. An example of this kind of law is the Republic Act No. 10913, which is the Anti-Distracted Driving Act. This was made and enacted by a governing body. However, the laws of nature are not like this. While laws of man are the prescribed rules that the society makes for itself, the laws of nature describe how nature works. To further emphasize, laws of nature are attempts to summarize the widespread display of order. They are discovered from repeated observation. They are universal because the purpose of these laws is that they aim for universality. Sure behaviors are being uncovered in the sense of being verifiable across time and space. They haven't changed for a very long time. Unlike laws of society, laws of nature are not made to be followed, as nature is used as a basis or inspiration for all laws. Example of this is the Johann Kepler's laws of planetary motion, which describe how planets move or orbit around the sun. They describe how planets actually move, and they do not prescribe how planets should move. Only us conscious beings can prescribe, since we are only capable of giving orders. But the uniformities of the nature would still occur and cannot be described by humans. All in all, we should always remember and take note that the laws of society are prescribed and man-made, while laws of nature are described and discovered. So we may still be confused in abiding by these laws. With that being said, Hospers emphasize the confusions to be avoided about laws. First is that laws should be obeyed. Laws of nature are not necessarily involved in obeying and disobeying, and not need to be obeyed or disobeyed, since it is not a command or order that has been given or prescribed. These laws describe how things behave, not prescribe how things should behave. Second, where there's law, there's a lawmaker. This statement applies only to prescriptive law, which are the laws that we abide by. Laws of nature are not prescriptive. They only describe how nature works. Hence, these laws are descriptive. And lastly, laws are discovered, not made. On the other hand, this statement applies only to the laws of nature. Laws of nature include empirical statements in general, but it is not solely based on simple observation. So, how are statements considered as laws of nature? We have 4 statements, and let us further discuss them one by one. So first, a law of nature is a universal statement. To visualize it, such example of this would be that all iron rusts when exposed to oxygen. If it doesn't consist of 100%, like it only consists of 95%, this is called a statistical law. A statistical law is referable to no law at all. So let's take this as an example. 95% of the affected students in UP who got infected by COVID-19 recovered from it is a statistical law. If it doesn't consist of 100%, like it only consists of 95%, then this is considered as a statistical law. However, being universal is not enough. Second, a law of nature must be open-ended. It must have an unlimited range in time and space. Third, natural laws must be expressible as hypothetical statements. This is formed through specifying information, variables, conditions, and in some occurrences, how we respond and connect to the different things we see. Just like in Galileo's perspective, he was confident that all bodies fall at the same rate in a vacuum and that only the atmosphere keeps them from falling at the same rate now. Lastly, the greater the generality of a statement, the more likely it is to be accorded to the status of law of nature. This is formed in the statement if all A's are B's, then all future A's will also be B's. Sometimes, the universal statement of the widest possible scope of discoveries are called a theory, not a law. This is why laws are important, because knowledge of laws to the extent that we have it enables us to predict future occurrences. However, what seems to be a law isn't always a law. Laws require qualification or correction. Sometimes further research and studies are also needed. An example is Isaac Newton's laws of motion. His formulated laws are still pending for future discoveries and are still needed to be corrected and be accurate. So, as Hospers emphasize that laws of nature are a special class of empirical statements. Hindi na sila nangyayari basta-basta. The things that we discover and encounter every day are not only based on what we learn and experience, but they're also based on the laws of nature and its different fields in science. These are not just simple occurrences, but they are in a wider and more complex occurrences. So, Now that we know the importance of scientific knowledge and the concept of the laws of nature, let's dive in deeper and look into how scientific knowledge really works. So scientific knowledge helps and enables us to explain why many things occur as they do. For example, why do dogs wag their tails? Because they're happy to see their owners. Scientific knowledge is applied to a lot of cases because we explain why something occurs. With scientific knowledge, we will be able to understand that explanations are not always answers to the questions why, but they're simply a request for clarification. We clarify or make occurrences clear through explanations to make them more understandable. Sciences are most concerned with explaining the why of events. Take note, they explain why events occur. We may ask why a particular event occurred. More often, we ask why or that kind of event regularly happens. But we can get far or explain further without introducing theories. So example of this is the origin of planets. This is something we cannot observe, but for a different reason, it happened before there were human observers. So this could also be considered as a theory. So scientific knowledge works when there is science. It is the basis of why things occur, when we explain how things work and how we perform things. Now let us move on to theories. And how are they connected with scientific knowledge? Occurrences are explained with the help of theories. But ano nga ba ang mga theories? They are never proved as they are always subject to revision in the light of further investigation that occur. In everyday use, a theory often means an untested hunch or a guess without supporting evidence. But according to science, theories are carefully thought out explanation for observations of the world. It does not only explain facts, but it also helps scientists to predict what they should observe if a theory is true. People might say that they can verify it, that is, confirm it all the way. That is to render or make it certain so that they can truly say they know it, not just have evidence for it, but know it. We might know it in the weak sense, but not in the strong sense. Nevertheless, a single observation is not usually taken as sufficient to disprove a scientific theory. Example is that even if no such objects were found in space, the planets, or the universe, astronomers would be more likely to trust the law than their ability to detect previous unseen gravitating bodies. Scientific theories are created or formed by a lot of empirical observation to build them up and even more to tear them down. If we find something wrong with one claim, we can place the blame on another one somewhere in the system. If something turns up that is not equal, this may refute the current prediction, but the theory remains untouched. So let's take this example given by Hospers. If it rains, the streets will be wet. The streets are wet, therefore it rained. Now, we will see this example as a logical fallacy, which is affirming the consequent. So, affirming the consequence is a fallacious statement or form of reasoning in which the converse of a conditional statement or if-then statement is said to be true. So, how did the given example become a fallacy? Because if the streets are wet, it might be because of a street sprinkler that has made the streets wet, or it might be a water line pipe that bursted that made the streets wet. This also applies to the scientific theory. If the theory is true, certain observable consequences will occur. Certain observable consequences do occur. Therefore, the theory is true. Then, is science based on a logical fallacy? Science is only based on a fallacy if it provides logical certainty. But of course, it doesn't. No scientific theory is forever unaffected to this confirmation. It just takes much disconfirming evidence before you will abandon it. So, since we already know how theories are applied with scientific knowledge, we also need to know how theories differ from science or scientific theories. To simplify, theories provide explanations to what and why questions, while science is proven and tested, answering the questions why and how. The goal of theories is to understand predictions among various phenomena, while the goal of science is to answer scientific questions and problems. So now that we have grasped the concept of theories and how it works with scientific knowledge, let us now explore the different theories in science. We are now halfway to our journey in scientific knowledge. First is the theory in astronomy. As we all know, when we look up in the sky at night, we see the moon, planets, and stars moving continuously across the sky from east to west, setting and then rising again some hours later. But we can see them when the sun is up. We see them all go around the earth so that we could be what could be more evident to our senses. This has seemed such an obvious fact to most people throughout history that anyone who thought differently was considered quite mad. So there are three kinds of theories in astronomy. The first one is the theory of the crystalline spheres. This theory seemed only a slight remove from obvious observed fact. This theory revealed that each planet had a sphere of its own, since each of their relative movements were different. And how were they discovered? The ancient Greeks and Arabs noted that the sun, moon, and planets move about among the stars. Although the stars were moving across the sky, they never changed their position in relation to one another. The pattern of constellations remained the same. The second theory is the theory of epicycles, which is also known as the geocentric theory. Ptolemy has observed and found some unusual occurrences or peculiarities in the motion of the planets. Ptolemy believed that the circle was the only perfect curve and that all the celestial bodies move in circles. But if you imagine them traveling in little circles, which are called the epicycles, around the big circles, then it can explain the erratic retrograde motions of the planet. There was no general theory that could predict the planets would move in epicycles, but once the theory is accepted, it was possible to use it to track the path of the planets through the years, and even to predict their future location. Even eclipses were predicted by this theory. However, Ptolemy added the variable of epicycles to his geocentric model. Thus, the geocentric model was justified by epicycles. Ptolemy proposed in his geocentric theory that the Earth was placed at the center of the universe, that the planets move around the Earth. The last theory is the theory of heliocentrism, or the heliocentric theory, which states that the Earth, along with other planets, are moving around the Sun. The Sun is the center of the solar system and the planets revolve around it. Both theories, Ptolemy's theory of epicycles and Copernicus' heliocentric theory, are just the same since they both explain the same observed data, but only Ptolemy's theory was more difficult to manage. However, the heliocentric theory disagrees with the geocentric theory and argues that the planets orbit around the Sun, not the Earth. Therefore, one observable consequence of the Copernican theory that does not occur under the Ptolemaic theory is if the Earth were going around the Sun in orbit in June, it would be 186 million miles distant from its position in December. Thus, this is called parallax. Parallax describes the slight difference in the apparent position of their nearer stars in relation to more distant ones. According to research, it was revealed that this theory took more than a century to become widely accepted. It turned out that Copernicus was correct about his claims because in 1838, the first parallax was discovered. No one suspected that even the nearest star was trillions of miles away. However, Copernicus died in 1543, just before his theory was proven to be true. Thus, we conclude that the heliocentric theory was simple in terms of explanation and its general principles, thus making this more accepted compared to the geocentric theory, which was found to be more difficult to manage. Even with powerful telescopes, the planets revolving around the Sun still cannot be seen. Now let us focus on another theory, which is the theory in geology. According to various methods of determining the age of rocks, these reptiles flourished for more than 100 million years until about 65 million years ago. They suddenly disappeared from the Earth. Why did they quickly disappear? With that, there are still questions that are still being asked. How did they come up with the theory of geology through these discoveries? How are the fossils explained? What has the theory explained to prove the presence of fossilized remains? What happened to the dinosaurs that were dug up in various places of the Earth? As frequently happens in science, a clue was found that seemed to have nothing to do with the problem. The period when dinosaurs became extinct was because and determined on the thin layer of clay discovered in a deep grove in Italy, in strata of rock at the boundary between a Cretaceous period and a Tertiary period. However, this has nothing to do with determining the age of Earth. So what does this have to do with dinosaurs? So the first one is that Oort cloud. But before that, we all know that dinosaurs became extinct and were killed because of the asteroids and volcanic eruptions. But let's look at this into a deeper perspective. Now let's go back to the Oort cloud. This refers to a vast array of comets found outside the boundaries of the solar system, which is beyond the orbit of Pluto, the farthest planet from the Sun. The Oort cloud is somehow connected to the cometary theory proposed by Aristotle. So, the cometary theory, if it is never found, which is the Sun's dark companion, will not count against the cometary theory. Empirical science testing procedures and assumptions were made to confirm this theory. The assumption was also made that the Sun has a dark companion star. There is still a gap in explanation, but if years pass and no dark companion to the Sun is discovered, some will say that it must be there. So we make inferences from our present observation of gas in the Earth, and so on, to past events such as huge meteorites hitting the Earth, killing the plants, and killing off the dinosaurs along with many other living species. Since we already talked the theories and also their discoveries, let's now move on to the theory in physics. So physics helps us understand how the world works, especially with the development of modern technology. There is no claim that anyone could possibly see them, even with greatly enhanced microscopic power. If there is no direct evidence for physicists, do they believe that they exist? So, since they are not observable by our senses or through instruments, one can say that they do not exist and say that these theories are nothing more than fancy ways of talking about the observed phenomena themselves. Electrons are inferences, but they do exist. So, with Lucretius' atomic theory, it explained that all things on Earth are composed of tiny particles that can be created nor destroyed. For example, when you cut a piece of chalk and rub it in your fingers or your hands, it results in coloring your fingers white. The small flakes of chalk are in turn composed of smaller ones, and these in turn of smaller ones. But at the end of the process, there are particles that cannot be split further, and these are atoms. So now that we already know the theory of physics, we learned that human and living things here on Earth do exist. But it seems impossible because inorganic matter is still present. So now that we know the different theories, let us now move on to the concept of emergence and reducibility. But first, let us discuss what emergence is all about. So these qualities emerge at a higher level than anything that preceded them. We could not predict what properties they would have in combination just from observing what properties they had prior to the combination. So chemistry is full of examples, like sodium is highly corrosive when exposed to air or water, and chlorine is a poisonous greenish gas, but when they combine, they form ordinary table salt, which is a complete knowledge of their behavior. We would never be able to infer that it would behave purposefully as organisms do. Consider how we humans adapt to different environments. The ways humans adapt can also be related to how animals behave in their environment. Through this, we should take note that emergence only occurs when reductionism fails. So now let's move on and understand the concept of reducibility. Reductionism is also involved in reducibility. From any number of propositions about inorganic matter, we could never logically deduce any proposition about living things. Because reductionism believes that everything came from simpler or more fundamental phenomena, especially when this is said to provide enough explanation. For example, thermodynamics has been reduced to another branch, mechanics, because the term heat is central in thermodynamics, not in mechanics. Therefore, we should also take note that chemistry has been said to be reduced to physics. Thus, if you recognize what physicists say about molecules, atoms, and electrons, all of chemistry follows. So with that being said, emergence and reducibility is a complex process to understand, and is still unable to provide sufficient explanation on how things are combined. It may still be unexplainable even with organic and inorganic matter. But biology can provide explanations. So how are all of these concepts explained in biology? In biology, we utilize explanation system of function or purpose. However, in physics and astronomy, we never have to resort to these. We use explanations of a kind that is quite different from what we use in physics, astronomy, and inorganic chemistry. Unlike inorganic matter, living things are born or hatched. They grow, reproduce, and die. Neither atoms nor stars do these things. We never ask such questions in physics. We are not told that the planets move in their orbits with the speed they do in order to keep them from falling into the sun. So, explanation systems of purposes are no longer accepted in biology when there is an evolutionary explanation. So, in biology, the purpose is used in the following ways. So, refer to this slide. Now that we have grasped the explanation in biology, we're now moving on to the exciting part, which is the last agenda or destination of our trip. This has been a controversial debate for a very long time. So have you ever wondered if life was created or evolved? How do they differ from one another? Let's discover what creationists and evolutionists believe about life was really formed. Creation and evolution, both of these play a vital role in how life was formed. Biology is still involved in creation and evolution, as this determines how things in the world are created. How did things ended up in existence? So, creationists believe that life was created by the Creator, which is God. Creation is a religious explanation of the existence of life. God initiated the entire evolutionary process, because it was confirmed through the existence of the flood at the time of Noah, hence the famous story of Noah's Ark. Their view of the origin of life is part of a far wider theory of the existence of God. Living things came to be. It is clear that they exist. It is not their fault if God's ways are mysterious that the scientific method cannot verify. Scientists don't entertain creationism as a possibility to be considered with, because creation doesn't have a scientific explanation. The chances of life arising from non-life are small. Then, evolutionists, on the other hand, believe that life arose under conditions that can be exactly duplicated today. Nothing in the creation story is explained scientifically. They don't appeal to God's ways to explain how life was formed. Evolution is a biological explanation of the existence of life. They do not believe that God created all living things and at the same time planted the evidence in the rocks. They also do not believe that God created all living things and the universe. Through the theories of geology or evolution, they argued that life was formed through fossils that were discovered, which resulted in them evolving into living things or life. These theories supported the evolution of living things as well as the universe. Creation is not subject to scientific testing. And with that, evolutionists say that it is killed or be killed. Life is millions of years of struggle for existence, with organisms surviving by killing and eating each other. And with that, we've now reached the end of our trip to the way the world works based on scientific knowledge. Before we conclude, let me know what's your favorite part of the trip. I hope you learned something from our journey and I hope you enjoyed it as well. Once again, this has been Maxine Dominique L, your tour guide of the day. Thank you for joining us. Till next time, goodbye!